We're going to do some work with log equations today. We're going to use an application that uses decibel rating. That's how we measure how loud sounds are. So decibel rating D is calculated as D equals 10 times log, that's log base 10, of I over I naught, where I is the noise intensity that you're measuring, and I naught is the fixed threshold noise. So the fixed threshold noise is the noise that an average person, the smallest noise that an average person can hear in a quiet room, okay? So what we have here is a ratio. So let's imagine that I is 10 times as intense as the quietest noise somebody could hear. What would that mean? That would mean that this noise I would be equal to, in that case, 10 times I naught, okay? The I naughts would cancel and we'd have D equal to 10 log 10 I naught over I naught. Now what's log 10? This says 10 to some power is 10. Log base 10 is just 1. So this would have this be a 10 decibel noise. Now you might say, it's 10 times the smallest noise. The decibel level is 10. That works great. Well, that's the only place that that works. Let's look at some problems and see how it works in practice other places. Okay, for instance, here's a noise. Find the decibel rating for a noise 100,000 times the smallest noise an average person can hear. Okay, let's see what that comes out to. This will also tell you why we use the decibel system. After you start getting a slew of zeros here, most people have trouble telling, what's the difference between 5 zeros, 8 zeros? But there really is a difference. And so the decibel system helps you to understand how big or how small noises are. So D equals 10 log base 10 of 100,000 I naught over I naught. We'll just cancel the I naughts. Now we have to ask, hey, what's 10 times the log of 100,000? Well, log of 100,000 says 10 to what power is 100,000? Well, since there are 5 zeros here, 10 to the 5th is 100,000. So that's 5. We call a sound of this intensity a 50 decibel sound, okay? Well, let's go the other direction. Let's say, how intense is a sound? You probably heard, say, a concert gets 85 decibels. 85 decibels is the level that experts think starts to risk hearing loss, okay? So how big a noise is that? How intense is it? Well, we need to plug that in for D over here. 85 equals 10 log I over I naught. Okay, this is not quite a basic log equation. I need to bring that 10 over to the other side. Dividing 85 by 10 makes it 8.5 log I over I naught. Now I'm going to convert it to an exponential equation. So this is base 10, right? So 10 to the 8.5 equals I over I naught. In other words, I equals 10 to the 8.5 I naught, or if you were going to think about what that looks like about 316 million times that smallest noise. Here we're losing track of zeros, so we describe this dangerous level as 85 decibels. Now, so how intense is a negative 15 dB noise? This is, so the smallest noise an average person can hear is this I naught. Negative 15 dB is the smallest noise that the best hearers in the world can hear. So just to give you a sense of where this range is, this is dangerous, this is the best ears around. So what do? We put in negative 15 equals 10 log I over I naught. Okay, we'll divide by 10 again, so negative 1.5 equals log I over I naught. Convert it to an exponential equation. 10 to the negative 1.5 equals I over I naught. So I is equal to 10 to the negative 1.5, which is about 0.0316 I. So that's over 25 times smaller than the sound most of us can hear. So that gives you some inclination of some intuition of what decibel rating is, and also tells you how to go about using log functions in practice.